I have brought a thermal imaging camera, and I just took a picture of you all. And the way it's just colorful. The dark is the colder, and the white is the hotter. And I guess the plan is to publish this somewhere, and the caption is going to be DDP, a bunch of hotheads. Okay. Well, we learned a little bit about the. Oh, okay. How you want to do this thing? We learned a lot about the history of El Paso the other day on the tour. And we learned that it's a really safe place because of the border control. And one thing she didn't say was that OSHA had been around and they had made things perfectly safe. And in fact, I talked to the OSHA people, and they told me there's an airbag up front. Oh, well, that passes for humor where I come from. Anyway, I'm going to be discussing the climate science here a little bit. And I'm going to make it so simple that even Al Gore and John Kerry could understand it. Maybe even Greta Thunberg. Each one of the three of them knows twice as much as the other two put together. Okay, they could probably understand this little bit of climate science if there's a way to make a buck by understanding it. So let us begin. This is a picture of Al Gore from his documentacity called An Inconvenient Truth, and it's a 600,000-year plot of carbon dioxide and temperature. And what you notice is that the temperature and the CO2 are going up and down together. And his implication is that the CO2 is causing the temperature changes. The CO2 changes are causing the temperature changes. Now, any climate scientist would be looking at that and asking a few questions. Mr. Gore, where did the CO2 come from? And where did the CO2 go that it caused the cooling? What caused those CO2 changes? None of those, the IPCC climate scientists did not raise those questions. They didn't ask those questions, let alone answer them. Okay, where were the climate scientists? Fooled ya. Okay. So where were the climate scientists? Why did they miss the obvious? I think there was one of the things that Al Gore talked about was some quote by somebody. I just don't remember these things, who said what, but it had to do with the fact that it's hard to convince somebody of a truth if his livelihood depends on his not understanding that truth. And Gore had that right. Now, it does take a little bit of expertise or a little bit of knowledge to ask why those oscillations in the temperature and CO2 match the oscillations in the Milankovitch cycles. Now, there's a process called Fourier transform analysis, which your ear does automatically. What comes to your ear is just variations in solar intensity. You interpret that as pitches, okay? Now, temperature versus time is a graph, if you will, of temperature versus time, but then you use a process called Fourier transform analysis in order to find out what the principal frequencies are. And if you take a look at the temperature graph and figure out the frequencies using this, there's a strong periodicity of 100,000 years, a little bit weaker one of 43,000 years, a little bit weaker one of 24,000 years. And those particular cycles happen to have the same frequencies as what's called the Milankovitch cycles. The Earth is going around the sun in an elliptical orbit, okay? And that elliptical orbit is nearly circular, but it does vary a little bit in what's called eccentricity. It sort of becomes more circular or more oval-shaped with a period of 100,000 years. Then there is, okay, think of the planetary system. Of all the planets are going around the sun in pretty much one plane. The Earth is going around in a plane we call the ecliptic for some reason. And the axis is tilted with respect to that plane by about 23.5 degrees. But that angle varies by a couple of degrees, 2.5 or so degrees like that, with a period of 43,000 years. And then there is the precession, that presently the Earth's axis points at the North Star, but it will sweep out like this, pointing, the star Vega will become the North Star in something like 12,000 years. The precession goes around like that, just like you spin a top and then it starts to tip over and it goes around like this. That period is 24,000 years. So any climate scientist ought to know that that happens, and he would take a little bit of expertise, but say, well, now why did those oscillations cause the temperature change if CO2 is the problem? Like, okay, let's take Al Gore's idea that the CO2 changes cause the temperature changes. Well, then how do the Milankovitch cycles cause the CO2 to change, which then cause the temperature to change? Doesn't it sound like it's a little bit bass-backwards? By the way, in all respect, Al Gore studied a lot of science, but he did it in kind of an unusual way. When he was driving to campus, he sat on his book and he absorbed all that information by what's called osmosis. Okay, let's see here. Okay, so where were the climate scientists? Did they really think that the astronomy was irrelevant? I don't think so. It takes a little bit of literature search. I mean, you have to be able to read and that kind of thing to discover a couple of papers. I'm sure you can't read the titles and so forth, but these papers are in Science. The top one there was in March 1999. The second one down was in March 2003. And these two papers have a couple of very interesting things in common. The first is that both of these papers show that the temperature changes before the CO2 changes. The temperature changed first, both for temperature rise and then the CO2 rise, and the temperature drop and then the CO2 drop. Okay? And both of those papers came before 2006, when An Inconvenient Truth was published. Al Gore is into retroactive causality. And it is I think he intends to commit or posthumous suicide. Okay, so where were the climate scientists? That's the message of this whole talk. It's actually going to be kind of a short talk, I think. Did the climate scientists fail to read papers in Science magazine? Did they believe in retroactive causality? Okay, anybody with a little sense would ask about CO2 in the past, and the climate scientists would surely know something about the history of CO2. Here's a graph with a bunch of data and kind of wide amounts of uncertainty and so forth. But you got to ask about that stuff. You take a look there. Now this is the time scale is reversed. In the previous one, the present was on the left and the past was on the right. Here, the past is on the left and the present's on the right. But there's a snowball Earth that occurred about 450 million years ago, when the CO2 was very high, about 10 times what we have right now. And over something like 99.9% of all history, there is no correlation at all between CO2 and temperature. Where were the climate scientists? Did they really believe that the low CO2 level would cause higher temperatures than high levels in the geologic past? I don't think so. UN framework on climate change. I think this preceded the IPCC by a couple of years, but they were the people who were going to get stuff set up. And according to them, there is no climate change before humans. It's a matter of twisting the vocabulary to bias the discussion. Here it is, and I took this from the sixth assessment report, which came out in 2021, but you can find it in earlier ones if you want to. The UNFCCC, in its Article 1, defines climate change as a change of climate which is attributed directly or indirectly to human activity. In other words, there was no climate change in the time of the dinosaurs because there weren't a lot of humans running around. And you thought I was joking. I mean, so, and by the way, there's a very interesting thing that's happened. Back when we were younger, by the way, I was born in 1940 at a very tender age. Well, anyway, when we were younger, the idea was this, that perhaps the CO2 was going to affect the climate, right? Now think of that in logical terms. There's cause and effect. CO2 is the cause, the effect is a change in the climate. Now think about what you read in the newspapers now, because I did a search the other day and found out something like a few 100 million uses of the expression caused by climate change. In other words, climate change has become a cause rather than an effect. I mean, you talk about these people who are in the business of distorting logic. You're beginning to get the idea. Okay, grade school science. Without any photosynthesis, there's no life. I got this graph from talk by Greg Wrightstone is a plot of carbon dioxide versus time for the last 140 million years. And the level has dropped from around 2,400, 2,500 parts per million by volume down to pretty close to something like 200 parts per million. If you get much below that, there's no photosynthesis. Everything dies. Got it? Al Gore, are you watching? But fortunately, we're kind of on the way back up, partly because of the warming. Oh, there's one more thing, and this is a very important thing. You go back to the graph of the temperature and the CO2 going up and down together over the last couple million years, where the CO2 changes came after the temperature changes. What do I mean by after? Well, the lag somewhere in the range of 200 to 400, maybe 600 years. Now, when we're talking about the present, we got to remember that there is also a time lag in the CO2 concentration lagging the temperature that goes back probably 200 years, maybe 600 years. Okay? So maybe there certainly is an effect due to our burning of combustible fuels. But part of that is just coming to what equilibrium might have come a lot later because of that big time lag. So, okay. Anyway, everybody ought to know that CO2 is necessary for life, even if you're a climate scientist. But we have people complaining that we have too much CO2. For example, Nature, this is an article in Nature, catastrophic change looms as Earth nears climate tipping points. And what it says here is that the global fossil fuel emissions are on track to hit a record high of such and such in carbon dioxide. He's worried that there's too much CO2. Not that there's too little, there's too much. And the same thing is occurring. This is from Columbia U. Good Ivy League school. Where were the climate scientists? Where are the climate scientists? Now, there's an interesting thing about the Earth's heat imbalance, and I'm going to show you some stuff. It's kind of basic science. This is a heat balance diagram that's actually taken from a group called CERES, C-E-R-E-S. It's not Willie's group, it's a different group. It has to do with satellite measurements and so forth. But the heat balance of the Earth, I mean, climate science is really, really complicated because you're dealing with air moving around and how much the Earth is emitting and storms and clouds and blah, blah, blah. That seems like a very simple-minded statement that the heat balance depends on three quantities. But you have to make a distinction, and most people fail to make this distinction between internal processes and external processes. Now, all that crap is internal processes. There's 50,000 PhD dissertations in there, but they're internal processes. The three quantities that matter are listed up at the top. Incoming solar radiation. How much sunlight is there at the orbit? The second one is reflected sunlight. How much do we reflect back out into space? And the third quantity is the outgoing infrared radiation from the planet, not from the surface, but from the planet as a whole. Now, what I want you to do is to think of a nice instrument that you have that can measure sunlight in orbit. It's out there in orbit. You don't have to worry about the Earth's atmosphere. And let's say that it has 1% accuracy. Now, if you look at some of Willie's papers, you find out that the solar intensity at orbit is, in round numbers, 1,400 watts per square meter. Now, if your instrument is accurate to 1%, that means you can read it to plus or minus 14. But what matters, at least for all of these calculations, is not the sunlight at the orbit, but the average over the Earth, because that's where it's compared over the spherical surface of the Earth, and so that turns out to be just divided by 4. So 1,400 over 4 is 350, but the correct answer is closer to 340. Anyway, if your instrument is accurate to 1%, you measure that 340 or whatever it is to plus or minus about 3.5 watts per square meter. Now, you can use the same instrument for measuring the reflected sunlight, because you're both measuring, visible light spectra and so forth. And so you can measure the outgoing solar radiation, and that too would be accurate to, 1%. What happens when you subtract them to find out the net? Well, it turns out that your instrument might be 2% high or 2% low, or 1.5% high or 1.5% low. You don't know, but it's somewhere in that range. But it's no different if you're looking at the sun or if you're looking at the Earth. So that instrument, if it is precise enough, now precision is different from accuracy. If it's precise enough, you may have precision of something like 0.01%. And you can very easily see variations. And you can very easily determine an accurate figure for the albedo or reflectivity of the Earth as a whole. That's the easy part. Let me tell you what the hard part is. The hard part is that you want to measure the heat balance of the Earth, which means you have to measure what's coming in and what's going out. What's going out is infrared, which is a whole different part of the spectrum, and your visible light thing isn't going to be of any value. You have to have a different instrument. So, presuming that it's also somewhere around 1% accuracy and 0.01% precision, you can go ahead and measure the heat balance of the Earth, and you might find out that the heat balance of the Earth is plus 3 watts per square meter plus or minus 10. Or something like that. You got it? Now, fiend that I am, I used to have my students do an experiment, which take a tape measure and measure the length of a table. Then take a wire, like a 12-gauge wire or maybe a 20-gauge wire, so we'll tape it down onto the tape, on the table, measure the distance from this side of the table up to this side of the wire, measure the distance from this side of the table up to the wire, subtract those two from the length of the table, and determine the diameter of the wire. You might find out that the diameter of the wire is -3 millimeters, plus or minus 5 millimeters. The thing is, the point is that in science, you always try to measure the difference directly rather than get it by subtracting large numbers. In the case of the Earth, you have no choice. To measure the heat balance, you have to measure with great accuracy and great precision. So, anyway, we'll talk about the external processes. Again, you're measuring the amount of sunlight at orbit, the amount of reflected sunlight, and the amount of outgoing radiation. You subtract items 2 and 3 from 1 and you get the heat balance, but you have to have very high accuracy and very high precision. Now, I don't pretend to know anything about those particular instruments, but the people that do it do. They pretend to know, I don't know. Anyway, the Ceres Satellites project was set up to measure those 3 external processes: sunlight at orbit, reflected sunlight, the amount of IR that goes out. It's called outgoing long wave radiation. I just call it IR, it's infrared, and it's the radiant heat that's going into space. And here is this is taken from a bunch of slides that Norman Loeb gave to his own group at Langley. I'm sure you can't read that, but it says HTTPS, so series.larc.nasa.gov/documents, blah, blah, blah. It's a PDF, so forth. I won't go over all of the incidentals and so forth, but I'll jump immediately to the conclusions. Referring to the EEI here, it says, now I've grayed out the stuff that is of no consequence for this discussion right now, except that up there where it says EEI, that is the Earth's energy imbalance. That's a number that's positive if we are gaining heat from the sun, or gaining net heat, or it's negative if we are emitting more heat than we're absorbing. It says the EEI trend is primarily associated with an increase in absorbed solar radiation, ASR, partially offset by an increase in OLR. Okay, and the large ASR trend, absorbed solar radiation, is driven primarily by reductions in low and middle clouds. Now, these are their conclusions. They were set up to measure the Earth's energy imbalance, and probably Al Gore had something to do this. We gotta prove this thing about global warming. They found out that there is an increase in there's an EEI, Earth's energy imbalance, is associated with an increase in solar absorbed radiation. In other words, an increase in I sun minus I reflected. Okay? And it's driven primarily by reductions in low and middle clouds. So why reductions in the clouds? They reflect sunlight. Take away those clouds and you have more sunlight reaching the Earth where it's absorbed more. Okay, can you say change in albedo? Now these are the numbers from the table. Now as far as they're concerned, they see just an absolutely trivial change in solar irradiance. They do see an increase in the in sunlight absorption between 2 periods, between March 2000 and February 2010. Is one period. The other period is March 2013 till February 2023. So that's kind of up to date. They see an increase in the absorbed solar radiation of about 1 watt per square meter. That's kind of interesting. Now, notice that those are basically 10-year periods. They have to take long-term averages because these measurements are very, 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 very hard to make. If you're going to look, say, for example, at the outgoing IR, you have to look at the whole Earth, day and night, average over long periods of time before you come up with a meaningful number. Okay, back to the conclusions. The EEI trend is primarily associated with an increase in solar absorbed radiation, partially offset by an increase in outgoing long-wave radiation. There's an increase in the outgoing infrared. Now think about the greenhouse effect. The greenhouse effect, I mean, it's perfectly real. It has to do with the fact that the atmosphere absorbs infrared and retains some heat within the atmosphere. The processes are very, very complicated because heat is exchanged between collisions and excitation and some IR, blah, 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 and all goes out and so forth. But there is a net reduction in IR from what's given off at the surface to what goes out to outer space. And if there's more of a greenhouse effect, then there is, at least temporarily, I mean, suppose we just suddenly increase the greenhouse effect. What happens is the surface continues to emit the same amount of IR, but more of it is blocked, so less goes into outer space. Then the surface of the Earth starts warming up and so forth and comes up until there's again a balance between what's given off the surface and what goes to outer space. But if there's an increase in outgoing radiation at the beginning, then that cannot be caused by an increase in the greenhouse effect. It's got the wrong algebraic sign. Give you an idea, there's the outgoing long wave radiation. It increased from 240.2 to 240.6 watts per square meter over those comparing those two 10-year periods. Notice an increase in the greenhouse effect would cause a decrease in the outgoing IR. So they have made a very strong case that the energy imbalance is caused by a change in low clouds, a change in the reflectivity of the Earth, not any change in the optical properties of in the infrared properties of the atmosphere. So Ceres is saying the planetary heat imbalance is caused by a decrease in albedo, not by an increase in greenhouse gas concentration. QED. Where were the climate scientists? Collecting. Now, some trivial algebra here. The heat is absorbed. The heat absorbed from the sun, this is for equilibrium. When we absorb heat from the sun, we emit exactly the same amount of heat to space for equilibrium. And the surface heat minus the greenhouse effect is equal to the heat that goes off to space. We emit something like roughly 400 watts per square meter from the surface, but only 240 goes into outer space, so 150, 160 is absorbed that's a net absorption by the atmosphere. But in any case, there's a simplicity involved. That is that the heat absorbed is the surface heat minus G. That's a pretty nice, all you have to do is know how to plug in the numbers and you got it. And if you look at Al Gore's drawings and you can interpret them correctly, that's what his drawing is saying. He didn't write them down. His book was still in the seat. Here's a very simple fact of life. See, there's a picture there of an IR thermometer, and I've got this magical thing here that I just took. By the way, I took that IR picture a while ago. I got to take a look at that thing here. All I see is a bunch of hotheads. Willie! Okay. Now, sometimes the most important things in science are existence theorems. There's one staring you in the face right there. The fact that that instrument can read the temperature of something is telling you that there must be a law of physics that relates the temperature to the infrared that instrument is going to absorb. Right? Simple. It's a very simple fact of life. IR thermometers work. And by the way, if you use the IR thermometer where they read your temperature at the medical clinic, point it at the wall and it won't give a reading. Point it at your head, it does give a reading. It gives you a false reading. It does not read the temperature. Actually, it reads the temperature of your skin, adds a few degrees to infer what the internal temperature is. That's why it's no good for reading a temperature of the wall, and so they just make it so that it doesn't give a response unless it's reading something in a narrow temperature range of body. Okay. Now, the IPCC tells us that doubling of CO2 results in two things. Number one, it increases the radiative forcing. That is the increased ability to retain heat within the Earth, and it stops the IR. And it amounts to 3.7 watts per square meter. By formula, they have actually used numbers up to 4. If you use the more intelligent figures from Will Happer, the figure is 3. I don't give a rat if it's 3 or 4 for this discussion. They say also that their temperature increase due to CO2 doubling is most likely to be 3 degrees, but the likely range is 2 to 5 degrees C. The Stefan Boltzmann law tells us, but climate scientists do not, that each increase of 1 degree C surface temperature causes the surface to emit 5.5 watts per square meter more. Okay? Now, if the temperature goes up 3 degrees, and each degree brings us up 5.5 more watts per square meter, that's 16.5. Do you agree? Okay. So how does the ability to stop an extra 3.7 watts per square meter possibly stop an increase of 16.5 meters per watts per square meter of IR? Al Gore tells us what the answer is. 3.7 is equal to 16.5 for very large values of 3.7. Okay, consensus. There's Al Gore saying the number disagreeing with the global consensus that greenhouse pollution has caused most of the warming of the last 50 years is 0. Now, at that time, numbers increased by the way, and thanks to the Oregon crew back there who have had the Oregon petition, oism.org. There's already this petition that had been signed by 17,000 scientists, which says that you should reject the Kyoto Treaty. Then there's, it goes on to say there's the, well, it says somewhere in there that that there's no reason to believe that this has any harmful effect on the climate. There's no convincing scientific evidence that human release of CO2, methane, or other greenhouse gases is causing or will in the foreseeable future cause catastrophic heating of the Earth's atmosphere, blah, blah, blah. Signed by, in this case, Edward Teller. This was all before Al Gore's documentacity. But anyway, 17,000 equals 0 for very small values of 17,000. Wherever the climate. Now, you can't read this graph. The IPCC is not alone in this, but they specialize in a couple of stupidities. Stupidity number S1 is to put the scales in microfont. Stupidity number S2 is to make those scales be in low contrast so that you can't possibly read them. So the numbers 2015, 2050, and 2100 are numbers that I put in. But I took this graph out of the sixth assessment report. The graph is representing various shared socioeconomic pathways, numbers 1 through 5, showing how much CO2 the planet, the humans on the planet are going to emit between now and sometime in the future. And of course that depends on how malicious the laws are, but anyway, that's what that graph means. And the lower part down here, it has a number of scales. One of them is the shared socioeconomic pathway, SSP, is followed by an immediate number, and then a dash, and then a number which is called the radiative forcing. So SSP1 in this upper graph is that low blue line, and SSP5 is the high line up there, the line that goes up toward the top. And the number that comes afterwards, and you can't read them here, I'm just circling them just to indicate that they're in the graph, shows what the radiative forcing is in watts per square meter. And the scale down here, this is all, the vertical scale on those bar graphs is always a temperature scale in degrees C, and those are the temperature consequences due to, the left-hand bar is everything put together. The bar next to the right is that due to CO2. The next bar over is the influence of other greenhouse gases, and the farthest bar over is due to albedo, primarily. Like, they always talk about aerosols. Okay, now I know you can't see that very well, but you'll get to see one in just a minute here. Now, this is kind of an explanation of what those numbers mean. SSPX dash radiative forcing. And this radiative forcing is occurring by 2080 to 2100, that 20-year period, and everything is referenced to the pre-industrial period, which is taken to be, in some cases, 1750, in some cases, 1850. Forget the dinosaurs. That's not pre-industrial. Anyway, the number that comes after it, they've only got 5 examples in there. For example, 1.9 means 1.9 watts per square meter radiative forcing from all causes, everything they can throw into the bag. And the one we'll be concerned with is the fourth one down, SSP-3, SSP 3-7.0, which means 7.0 watts per square meter radiative forcing from all causes, again, reference to the pre-industrial period. Now we'll take a look at this graph, and I have just made that graph large enough that I think you can read it, but down at the bottom, you'll see it says total observed, and there's a dark part on the first bar, which indicates the changes that have occurred from pre-industrial to now. I wrote the word now in there. And again, the first column is total of everything. The second column is that due to CO2. Third column is due to non-CO2 greenhouse gases, primarily dihydrogen monoxide. And the fourth one is aerosols and land use. Okay, that basically means reflectivity. Again, now, emphasizing that the total radiative forcing from everything they can dream up is 7 watts per square meter. Now, I was unkind enough to add a scale. This is a very simple scale. If the temperature goes up by 1 degree, that adds 5.5 watts per square meter to the IR we emit. So the scale over here on the left, increase in surface IR in watts per square meter, is just put in there to match the temperature increase scale, okay? So the long and short of it is that 7.5 watts per square meter total increase in ability to suppress IR is somehow supposed to block 20 watts per square meter. I got a bridge for sale. Goes into Brooklyn. Where were the climate scientists? Exeunt stage left. They all left. Okay, that's my story, and I'm sticking to it.
All right.
Thank you.
Okay, we do have a few minutes for questions.
I read recently that our current CO2 of 0.04%, I can't think of the name of it, the absorption from the frequencies, the CO2 turns into heat. There's a couple of them, or one of them, but that absorption figure was essentially 0.5 per 1.2 meters. So if you went up 12 meters, which is about 40 feet, the infrared available from of those frequencies available from the Earth has already been absorbed.
Well, let me explain that just a little bit. The absorption cross-section is a measure of the probability that you absorb IR, and it is very, very highly frequency or wavelength dependent. If you take the peak of the curve, which is at about 15 microns, at present temperature, you have essentially absorbed all the IR in 20 lousy centimeters. Okay, but that's not true for the whole thing. But it's a good deal more complicated than that, because what is happening in the molecules, those molecules are colliding. I mean, the molecules are moving pretty much at the speed of sound. And there's nitrogen and oxygen molecules, and so collisions are the name of the game. So let's imagine this, that here is a carbon dioxide atom, and it has absorbed some IR So it has increased the energy so it can have a little bit more vibration, okay? Along comes a collision, that energy can go into that colliding molecule. And then another molecule comes along, collides with it, and it starts doing this, and it might give it up by collision to something else, or it might give off IR. So now what happens is then that the populations of these excited states are temperature dependent. So there's an equilibrium. Let's say it's 22 degrees C out. There's an equilibrium in a region that a certain number of those molecules are excited and ready to radiate IR. There's always a certain number, and it's a temperature dependent thing. And as you go higher, the likelihood of those things decreases a lot. But it's a very, very, very complicated kind of procedure. Now, if you look at the IR that goes into outer space, there is a dip in there for CO2, because CO2 is a big absorber, but there's a peak in the middle of that dip. The peak in the middle of that dip is telling you something very, very, very important. But you remember, a good radiator is a good absorber. A good absorber is a good radiator. That peak, which is presently absorbing at, like this much distance, is the primary emitter in the CO2 spectrum that's going into outer space. So that you have to take into account the exchange between the excited states and all the collisional energy and all that kind of stuff. And the real experts on that are people like Will Happer and Will Van Weingarten and so forth. But if you look at the spectrum that was measured over Guam way back in 1970, they had a theoretical calculation in there that fit the data very well, with one exception. They didn't think of O3. But otherwise, they did not think of ozone. But otherwise, it was a beautiful fit. And Happer and Van Weingarten did marvelous work, but it was just using higher precision data. Okay. Joe.
All right, Harold. You ready for some good news?
Yeah.
All right. So as soon as you started your talk, I went to ChatGPT, and I added in the question, in the geologic record, why does the increase in CO2 lag the increase in temperature? The answer: the phenomenon where an increase in CO2 lags temperature is due to long-term changes in orbital cycles driven by the Milankovitch cycles. As the Milankovitch cycles increase, as the temperature increases, the oceans warm, releasing more CO2. And they have a summary comment at the bottom: long-term changes in climate are driven by changes in the orbital mechanisms of the Earth and Milankovitch cycles. Ooh.
Hey, Joe, you can't be all bad. Thank you.
Time for one more. About 6 months ago, the Epoch Times ran an article. I can't remember the name of the scientist, but he talked about clouds being kind of the Earth's corrective mechanism. Would you comment on that compared to what you talked about?
Yeah.
Where's your
Yeah, John Clauser. Yeah. Well, it's you go back to that first thing, that the amount of heat absorbed from the sun is equal to the amount of sunlight we get minus the amount that's reflected, and the clouds are reflective. So it's tied up with that. Shoot.
Thank you, Cork. I wanted to remind everybody here, Will Happer, as he just mentioned, one of his slides shows exhalation from the human body is 4% carbon dioxide. It hasn't changed since I was in medical school 60 years ago now, believe it or not. So I would still like to get into a debate with somebody, and now, 4% is 40,000 parts per million. So for those people that are worried about going from 400 to 40,000, I would like to have a little conversation with them. What should we do if it goes from 400 to 800? Should we regulate it and eventually work them into a tizzy? Well, what about 10 times? Should we eliminate it? Well, maybe not. 40 times? Do away with all point sources? You just gave yourself the death sentence. So that hasn't happened yet, but I'm awaiting an opportunity.
Bob, you realize that you're breathing too much?
I know, I love it.
80,000.
Okay,
Very good, Cork.
thanks.
So there's a fellow named, I think it's Pokrovsky, who used International Cloud Climate Atlas and found the decrease in cloud cover that corresponds to your increase in
And absorb solar
right.
energy.
It fits the measurements. That's number one. Number two is there is this thing that we learned in high school physics about high school chemistry about Henry's law. And Henry's law says if you heat the water, like the oceans, then the dissolved gases will come out. Well, some of the dissolved gases is air. And what's air? 78% nitrogen, 21% oxygen, 1% argon, and now 427 parts per million carbon dioxide.
Absolutely.
That explains it. High school chemistry.
Yeah.
This is sort of just a little trivial thing, but I think you had the quote, "It's difficult to get a man to understand something when his salary depends on his not understanding it." That's Upton Sinclair.
Good, thank you, thank you. I have a very good forgettery. Okay, thanks, folks.
Okay.